Welcome back to Neal on Fire, where we talk with people building the future of wildfire detection, mitigation, and response. I'm your host, Neal Spungen. Let's get into it. Today, we're joined by Melvin Sieben, CEO and founder of Mejor Technologies, a company building advanced tools for real-time wildfire incident mapping for first responders. Their solutions like Chris Cloud, Lucy, fast, and off-grid deployable systems are redefining how we detect, map, and understand and respond to high-risk events. I'm excited to explore how technology like this is changing the outcome of wildfires and other incidents around the world. Melvin, thanks for joining the podcast today.
Thanks for having me, Neal. A lot of fun to be on. Thank you.
So what gap did you see in wildfire and incident response that others weren't addressing that led you to create tools like Lucy and Chris and the company in general?
Yeah, interesting question. So me and my business partner, Joris, we met as former colleagues at a different company. And we were both engineers. My background is in applied physics and he's a mechatronics engineer. And we wanted to use our knowledge to create positive impact to some issue. So we went with wildfires. My wife's from Australia. She comes from an area where there's a lot of fires every year. And we started investigating the problem. And we saw in 2019, a lot of people were already working on different things. But what we missed then was an early detection system. So satellites were coming up, but you didn't have the big systems yet, like Aurora Tech coming up, or like 10 or 20 constellation satellites already in orbit. They were relatively small still. So first we thought of an early detection system using drones. Years of development later, we found out that, okay, the drones was also a very difficult market to be in, and certain players were already very developed, things people like DJI to compete with. So we went and designed two systems that were still part of the initial idea, but had two different use cases still. One of them was that we found that there wasn't enough high resolution and quality insight into fire risk. And I must say, when I say risk, I must say wildfire susceptibility. I've learned from my academic peers. That's the right way of saying it, because it's really the chance of a fire starting in a certain location in a certain time. We found that there wasn't widely and publicly available enough, or sometimes it wasn't explained properly enough. Like, is it always weather? Or is it only just the state of the fuel? Or aren't there other parameters that can be contributing there as well? So that's how we started with Lucy. And the Chris part is that we saw that already a lot of firefighting agencies, even in the Netherlands, where the problem is relatively small compared to especially the States, they were already using drones, but they lacked an overview of what the drone could see. And in Europe, you're not allowed to fly very high. So that means that, even when you had a drone and it was the first firefighter to arrive at the scene, sometimes you still missed that larger picture, especially when a fire was spreading quickly. We had this anecdote of a firefighter said, yeah, if it's too big, I'll call on a helicopter anyway. And we thought there's a more intelligent way of handling that. These drones are very cost efficient. They're super dynamic. You can, there's a high resolution sensor on it. You can see a lot of detail. Why can't we build something to create that situational awareness overview and share it, make it shareable, so a lot of eyes can look at this single source of truth?
So for the person in the wildfire space that is getting overwhelmed by all these tools, all these things coming out, give me the simple version. What is Chris Cloud just simply, and what does it do, and why does it matter?
Yeah. So imagine you're a firefighter and you have a drone that you can fly, and you can fly it up to 100 meters, and you're responsible of giving the overview of the situation. That means, where is the fire? How fast is it spreading? Are all the roads available? Are there people nearby that need to be evacuated? Where can I get my water from if that's not in an urban area? And you need to get all that information with your drone to the officer that's responsible for mounting the response. Then if you only have the drone, that means that you look through the sensor onto your little controller, and you have to then somehow convey that information to the officer. So either you call it through, you're telling him, well, I see this thing there, I see a fire progressing there, but there you can't combine all that information. So simply what we do is that when the drone is flying, we take all the effort out of the hands of the pilot. We just connect to that drone, and every time that it makes a picture, we map it. And we map that geo-reference, so the image is in the right location. All of these drones that we've worked with so far have infrared sensors as well. So that means that they can measure temperature. That means that we can see the difference between a fire, the background noise, and a person, for instance. And we map that out as well. So when the drone is flying, you can see, first of all, if the roads are still accessible, because you have this new image of if there's a tree over it, yes or no, but also where is the fire currently. And because you're flying not only above the fire, but also in the neighboring areas, you can see if there's people that need to be evacuated there. And that image is directly within seconds synchronized with the backend as well. So the pilot is seeing it locally, but because it's connected through the cloud, the officer that needs to build this response gets to see this map as well. And the pilot can just focus on flying, and the officer can just look at this image and build this response around it.
That makes perfect sense. Now, you have multiple products in your line. You've got Chris Cloud, Chris Off-Grid Box, Lucy for risk prediction, and Fast for monitoring. How do all these work together as one unified system?
Yeah. So like I said in the beginning, we started with this early detection system, and that is actually fast because the fast system was designed to, over a larger area, distribute drones in an optimal way so you can detect a fire early. And fast is not something that we're focusing on too much right now. It's mostly Lucy and Chris. But for the fast system, we needed to have some indication of where the fire risk would be, because otherwise you need to hang drones everywhere. And then you might as well buy a satellite because then you're spending so much money. There's no business case there. So the Lucy system is really there to create insight into the fire risk first. And with that, you can do a variety of things. The forest managers can do prevention efforts over maybe even months before the fire season even starts. And they know, because our resolution is 10 by 10 meters, they can really pinpoint it very accurately. And it can also be that you're just more prepared. We can also predict this susceptibility up to 14 days into the future. That means the fire season is already there and you don't have time to do any prevention efforts anymore. You can then still be more prepared or aware of when the fire risk will be increasing. And the CRIS system is really there to respond. So we know fires will happen. We think that prevention is the way to go, to organize the landscape in a way that is that the susceptibility is lower, to educate people on the fact that fires will be, even in the Netherlands and the northern regions of Europe as well, will become a normal part of our living. But then still, when they do happen, we want to facilitate the firefighters to have the best tools available so they can communicate what's going on in such a way that we can lower the damages and save lives, hopefully.
So from what I hear you say, Chris can ingest drone imagery, live video, aerial data, anything else that is part of the ingestion of data for the system?
No, so for Chris, we only use what comes from the drone. And we make sure that we map it and we draw these fire polygons that give an outbound of where the fire is currently. And if you fly over multiple times, you can see how the fire has been progressing. So you can also, in the next software release, we'll have also these vectors that show you between now and 10 minutes ago, the fire on this flank has been progressing with this speed, for instance. And that's a layer that we add to the system. But we have a future development. It's actually quite an interesting one where we're trying to connect Chris and Lucy, where we would also extract certain vegetation data from the CRIS data. Because in our conversations in the UK with a forestry agency, they do these things by hand sometimes now. They fly over with the drone and they subtract the location of certain vegetation or the state of certain vegetation from these drone images by hand. And what we want to do is to do that with machine learning. That's, of course, it's been used like that a lot. But then we would make that also an input parameter to the Lucy system. Because now Lucy only uses these publicly available satellite data, which often quite coarse in resolution. But then you would have this high resolution drone data very locally and very recent. And if you make that the input parameters to the Lucy system, then the output becomes much more reliable and recent as well. So that's a combination that we have that plan for 2026, though. That's a collaboration with the UK part.
I am intrigued by the off-grid box. So how does this thing work? How does it connect with Chris? What does it do in remote environments without any connectivity or power? How does that work?
Yeah. The Chris off-grid box is a cool system, completely built by hand by the first version, at least by my co-founder Joris. This is his expertise. And this is a box we built for redundancy. We think in the wildfire space, minutes, even seconds can make the difference. So we have this, like you said, the Chris Cloud solution. We can connect directly to a drone. You don't need any hardware, and we can build these maps and we can export them even as a data layer to an external crisis center where they can be visualized. But sometimes even in the Netherlands, there is no mobile network available. So how do you connect then the drone, or how do you then still get these overview maps and there's relevant information to the officer that needs to build this response around it? And that's why we built this off-grid box. So the idea is it houses a drone. The current version houses a DJI Mavic, but you can build it to house any type of drone. And we have a dedicated piece of compute hardware that's part of the box, and we have internal batteries as well. So the idea would be that if a fire happens and it's in an area where there is no electricity, there is no mobile network available, the drone pilot would come with this box to the situation, get the drone out, fly, and the box would make a local network where any mobile device can see these maps being made in real time. So even though it's not synchronized with any backend, this pilot or maybe his colleagues that are maybe on the front line even can have a mobile device strapped to their wrist, and they can still see in real time this situation and being created for them, this overview map of the situation being created for them. And if the box does get a connection with the backend, it gets synchronized again. So then all of these maps that are being made are still available to the incident or the crisis center or whatever it may be. And so you have all this redundancy built in. And the current version that we have can be off grid for approximately 5 to 6 hours, which is more than enough. You can charge it with an external power bank also. So,
well, let's talk about one of your other children, Lucy. So Lucy focuses on wildfire susceptibility and risk modeling. And what goes into predicting where the fire is most likely to occur, and how accurate are those scores?
Yeah, that's a very interesting question. So just to make you understand a little bit more about what Lucy exactly is, Lucy is a software platform that houses multiple machine learning algorithms that predict wildfire susceptibility. And why a platform is we wanted to automate this process. So if every region is so specific, you need to have a machine learning algorithm trained specifically for that region. There is no one algorithm that can cover the whole world with the best accuracy. That's not possible. But you can have multiple, and you can also automate the process so that if you have identified, okay, for this region, it's these parameters that are most predominant. We have an algorithm trained and we've validated it. So it's, and accuracy is always very difficult to say with machine learning, but you can say, the 80% of the times a fire happens in the top 20% of highest risk, for instance. You always have to look at the area if that makes sense. And you can't always say, okay, that's a good score. You always have to see, what else is going on. But let's say this is how you measure it. And that needs to be visualized in some sort of a map. So if you can make that whole flow be automated, that means if somebody wants to have a prediction and they're in Portugal, and somebody else at the same time wants to have a prediction but they're in Canada, they can both prompt the system at the same time, and within a couple minutes, this forecast for the next day would be available. And we wanted to automate this as well as possible so we can facilitate as many different people. Let's say there's, in a year time, 500 different algorithms running for different areas in the world, that they can all get these forecasts out in time. And also if they want to run any historical analysis on what happened in the past, why we have this fire in this area, I don't understand why. Is it maybe the infrastructure or the human activity that's happening? You could add a certain parameter to the system, and Lucy would then, because it's an automated process, add that parameter to the machine learning algorithm, retrain it, validate it, and create this overview map again. So you can do a lot of analysis as well. So that last part of really adding parameters is something that we built a structure for. And in 2026, we can release that also to the public.
So for the firefighter who is using FAST, give me a sense of what visibility does the platform give to them during an evolving event? How does that work?
Yeah, so again, the FAST system is a combination of Lucy, a drone system, and Chris. And a Chris, of course, we never use without a drone, but the customer would already have one. But the FAST system, as we built it initially, and we have actually a version with a drone partner of ours called Tective. They have a drone in the box solution. They have 5 drones in a small trailer that's mobile, but you can also install it in a certain location. And those drones can autonomously land on the trailer and click in a new battery. So that means they can fly for 45 minutes, and if they're depleted, they go back, click in a new battery, and then again, they're available for 45 minutes. So that would really be if there's a large fire that you want to have monitored continuously, and you don't want to scale all these drone pilots in all directions, then the FAST system would do that. You would come with this trailer, the drones would go in the air automatically, they would find the fire, they would start visualizing with Chris, mapping out the situation, relaying all that information to all the stakeholders that need to look at it. And continuously, the drones will be landing and clicking new batteries. So you would have up to 200 hours of of autonomous monitoring. But FAST is really a vision that we have. And technically, I think it's possible. It's just legislation in Europe right now doesn't allow it because autonomous flights is still a problem here. But that would be the idea. You would have, even if the fire is hundreds of thousands of hectares, with a couple of those systems, you could just autonomously monitor, have all the benefits of the drone and no downsides, basically, because you have so many and you have this autonomous battery clicking in and out that you have the uptime as well.
So, given those limitations for drones in Europe, do you have a real world example of a deployment and maybe some examples of the difference that it made during an active event?
So we had an MVP release of both our products in the beginning of this year. And then we started to do pilots with relevant fire agencies in the Netherlands. And we did a demo as well in Bulgaria through the Fire Resilience Open Innovation Challenge project. And the only thing we've done so far is test it in a relevant environment, but not above active fires. So we've planned some prescribed burns where we will test the system. That will be in February next year. But otherwise, what we've done is that we've lit fire together with firefighters, and then with their drones connected, send up and started mapping with Chris. And then we would check how fast this data would be available. And the anecdote that we compare it with is that in the past, in the Netherlands, they would draw out where the fire and the situation is by hand on a different tablet. So the pilot would be looking at the situation. Another firefighter would be standing next to them and they would draw in, okay, this is now what the fire is. And they had a whole protocol to that. That could sometimes take 30 minutes. And these tests that we did with them is that the first image was available within 20 seconds of it being taken, geo-referenced with a fire polygon in this dashboard. So as the fire was growing, and we also tested this on larger areas, but with the temperature threshold lower. So for instance, at 40 degrees, so it would detect plaques of land that were elevated, for instance, tarmac or things like that. And that means that a large area of a couple hectares, within 3 to 4 minutes, you would have completely mapped. And you would have your first overview. So that means you can save 30 minutes or more, sometimes in these situations, of getting that first response. And that can save a lot of time and money because then you know where to go, where the high risk points are. You can validate that the fire is progressing in a certain way. You can overlay it in our dashboard or in your dashboard with wind factors. So you know, okay, the fire is here now, the wind is in that direction. We probably need to, mount the response more on that side or evacuate more on that side because we know it's going to be there. So that would be the true benefit of the CRIS system. Yeah.
So I know that wildfire is your primary focus. Are there other sectors where you see that this technology could be applied?
Yeah. Yes, actually, we've had multiple conversations. One very interesting one is that in the port of Rotterdam, for instance, that there's a lot of chemical warehousing. And there's fires there as well. Actually, one of the larger drone teams of the Netherlands is there. They're very sophisticated. They have a lot of the new technology. And they use drones every time that they have some sort of a fire call. And the situation you can imagine there is that if there's some hotspots are different than others. Sometimes it's something relatively small and low risk. But you can imagine if some chemical plant is on fire, if there would be an explosion, there's also a risk of infecting people with maybe some substances that shouldn't be in the air. So there also, if they have a limited amount of drones and they need to scout an area very quickly, they can use CRIS for that because we can see the differences in temperature. So getting a 2D map of this situation within a couple seconds and then being able to pinpoint and do triage on these points by saying, well, here the temperature is relatively low. We can leave this one for, in the next half hour, but this one is already at 700 degrees. We need to evacuate here immediately. So we call that industrial complex fires. That's an application, definitely. Another interesting one, actually, that we are having a couple conversations with in the Netherlands and Belgium is in ports. So the port, for instance, the port of Antwerp, there's a lot of boats moving around and there's security issues, of course, but also they're not allowed to stay in certain locations for too long because new ships need to come in. So they need to manage that continuously. And they have a lot of drones flying also beyond visual line of sight. So again, very innovative parts within Europe. And their 2D mapping can be very handy as well, because if you have within a couple minutes an overview of the situation, on the ship wall, on the port wall, then you can decide also if you need to move ships around. And there's even a business case behind it, because if the ship is there too long. you lose money. And there are other use cases you can think of. If people go skiing and you need to find them quickly, you only have one drone. Might be nice to very quickly fly over and find some heat signatures in certain locations. There are security, and also nowadays, of course, in Europe, very hot topic defense, something that we're not in currently, but we get a lot of questions about that at least. But currently, we're focusing on creating positive impact first.
So all of this technology, drones and the software, everything is evolving so quickly. Are there certain features or capabilities that you're excited about that you might be able to integrate over the next year or two?
I think for the Lucy system, there's so much going on these foundational models for weather prediction, and that can really improve our forecasting functionality. Because I think you asked that question before, but Lucy takes a variety of parameters: weather, vegetation, fuel, moisture in the ground, moisture in the air, topography, the things, but also human activity, things like infrastructure, other measures for human activity. But for the forecast, we only use the weather basically, because all the other parameters, things like infrastructure and vegetation state, is not going to change much in the coming 3 to 4 or 5 days. For that, you really, the more predominant parameters there are the weather. So if those models become better, we can probably forecast it even more time in advance. So that's what I think is super exciting. And drone technology is going so quickly. Yeah, in the Netherlands, there's a lot of trained, really proficient drone pilots. We're really investing in that a lot, but that also makes it less scalable. I think on the short to mid long term, having some freedom in flying beyond visual line of sight, or even having one pilot that's in control of multiple drones that have some autonomous capabilities, will make it that even this kind of mapping, and you can still use the CRIS system, will go much faster. So yeah, that's what I'm truly excited about. That would be the ideal situation, right? That you have just a drone flying completely autonomous that detects it early, even before the gap of the satellite, if it's going in orbit and you're missing something there, and then there's an autonomous system that extinguishes it, that we both know of. There's a lot of attraction in the market going on there as well. But I think those things might be quite far away. But there's a lot of incidents, smaller steps in between for the coming 20 to 30 years that will also make it much better.
So looking even further ahead, what's the long-term vision? I mean, what do you think wildfire and disaster response could look like if tools like Major become standard practice globally?
Yeah, that's a very interesting question. I think even in Europe, south of Europe, definitely, but even in countries like ours, I think people are understanding that this will become a normal part of life, and that we need to really think about how to live with it, and that we can't always fight it. I think it's a natural part of the ecosystem. It's cleaning itself up. So the fires are also necessary to lower the risk for the next year. I think ideally, Lucy, we have this very known app in the Netherlands called Buienradar. In Amsterdam, everybody uses it. What it does, it just predicts the coming 3 hours of weather very precisely, where the rain will fall. And in Amsterdam, everybody rides a bicycle. So 5 minutes of knowing, all right, I got a little gap here now. I can cycle to the supermarket and back. That's super valuable. I can imagine that people would just use Lucy for that if they are going on holiday to Spain. And they just check, okay, I'm going to that area. Am I safe there? And I think educating people in knowing, for them to know that this is a normal part and we need to work with it, that takes away the fear part, right? There's a certain transparency that makes it that people like, okay, well, we'll work with it. And also it makes them more responsible maybe in limiting the chances, right? You'll maybe a little bit more adapt to not throwing away a cigarette if you're a smoker, or to throw your trash in the right bin so you don't have some light reflection of, I don't know, just you're a little bit more aware of that. I think that's what Lucy can definitely do on the larger scale. And of course it would be super cool if we can keep collaborating with all these academic institutes. There's a paper being released that's co-authored by us in the coming months with the VU University here in Amsterdam. There's so much work going on there, and with that collaboration we can really have enough insight in how to prevent these things and understand them better, that we're better prepared. They will happen, but at least we know why and where and when, and we can use that in our educational system. And then on the other side, again, I think CRIS will evolve in a lot of different directions just to support the firefighters better, so that they know that they have the tools to safely go into the field and risk their lives for us, and to be able to battle this fire and get it under control. yeah, that would be my dream for Chris. And we just signed our first partnership with a firefighting agency in the Netherlands, and that's going to be a 2-year collaboration also on thinking about which direction does it need to go, and like you just said, like which developments in technology are we expecting, and how can we use our expertise to add to that instead of doing the exact same thing and trying to be competitive in the market. Like really, how can we get these firefighters the tools that they need to fight these things and make us all safe?
So we've talked extensively about all the components of your system. Is there anything we haven't discussed that you think listeners should hear about?
No, I think of the systems not so much. I think what I do want to share is again this collaborative notion that we have. Is I think there's a lot of players in the market, and I think almost everybody that you speak to, they have this vision of contributing to the positive impact or to the solution of. And what we always try to do in all our products is to make it that we can be a part of other systems as well. So with Chris, we have a dashboard, but everything that we build can be an export to a visualization system, because I know in the Netherlands there's already 3 varieties of different dashboards. We don't need to build another one. And I think we will keep that design principle with us as we move forward into the future. We want to make sure that we get these solutions onto the market as quickly as possible so we can get this positive impact out there. So that means that it's better to collaborate than to be competitive in that sense.
Melvin, thanks so much for joining us. It's been great talking about the entire family of products, Lucy and Chris, and I love the names. I think it was really smart to come up with names that people can connect with. There's so much that's wildfire this, flame that, and I think that's really clever. So thank you so much. I think tools like yours have the potential to save time, resources, and lives. And it's really encouraging to see the innovation accelerating at this pace. So thanks for joining us on Neal on Fire, where ideas ignite and solutions spread. Subscribe, stay connected, and join me for the next deep dive into the future of wildfire technology.
Thanks, Neal.